like Hun 3 magnetostatics of gift 16. This problem we have two infinitely long currents, conductors with current 1 and current 2. And it's said in the problem that these conductors intersect the plane, this in yellow color, the plane where z is equal 0, at the point x1, y1, and at the point x2, y2. And it needs to find the resultant induction of these two conductors. So at the point x, y, z. So again, by the right-hand rule, both currents are flowing in the same direction, so the resultant induction is curling around the current, and also directed in the same direction. We have induction V1 and V2. Then the resultant induction would be a sum of inductions from both conductors. In the previous problem, we found induction in cylindrical system of coordinates, and now we need to find it for the points x, y, z, so in Cartesian, or rectangular system of coordinates. So taking into account the formula from the previous problem, we have their r and phi direction, which belong to cylindrical system of coordinates. So to do the transfer from cylindrical to Cartesian, we can get help from the pink pages. In page 1, there is a transfer between two system of coordinates. Let's write it for the phi unit vector. Can be expressed as following. In this case, cosine and sinus phi refer to the following. So if we draw both systems of coordinates at 1, so we have here x and y, and then we have also r, and this is the phi unit vector. The phi angle would be between x-axis and r vector. So this would be our phi angle directed in the phi direction. So then the sinus and cosine can be expressed by means of projections on the axis. So that this part would be the x projection, and this part y projection. Then let's write for the sinus. Sinus phi is y divided by r, the magnitude of this unit vector r, and the cosine, the same, just x divided by r. R in both cases. For this example, we have a triangle with a 90-degree angle, and for this, the R is square root out of x squared plus y squared. So we found sinus and cosine, and then we can write, and we know also what is R. for Cartesian system of coordinates. So going back to our induction equation, we can write times y. So I have the following. So this 2 we can bring to the following form. So that the general form right now, but we are given that each current passes through a point x1, y1, and then for the b1 can be written the following. So, and it's true for all z points. Now we can write for the b2. So this was current 1, this current 2. Also valid for all z. So to find the resultant B field, we just need to sum these two B fields. We have the following answer. That's the following answer for the problem.